In electronics, a diode is a two-terminal electronic component that conducts primarily in one direction. It has low resistance to the flow of current in one direction, and high resistance in the other. A semiconductor diode, the most common type today, is a crystalline piece of semiconductor material with a p-n junction connected to two electrical terminals. A vacuum tube diode has two electrodes, a plate and a heated cathode. Semiconductor diodes were the first semiconductor electronic devices. The discovery of crystals' rectifying abilities was made by German physicist Ferdinand Braun in 1874. The first semiconductor diodes, called cat's whisker diodes, developed around 1906, were made of mineral crystals such as galena. Today, most diodes are made of silicon, but other semiconductors such as selenium or germanium are sometimes used. Main functions. The most common function of a diode is to allow an electric current to pass in one direction, while blocking current in the opposite direction. Thus, the diode can be viewed as an electronic version of a check valve. This unidirectional behavior is called rectification, and is used to convert alternating current to direct current, including extraction of modulation from radio signals in radio receivers. These diodes are forms of rectifiers. However, diodes can have more complicated behavior than this simple on-off action, due to their nonlinear current voltage characteristics. Semiconductor diodes begin conducting electricity only if a certain threshold voltage or cut-in voltage is present in the forward direction. The voltage drop across a forward bias diode varies only a little with the current, and is a function of temperature. This effect can be used as a temperature sensor or as a voltage reference. A semiconductor diode's current voltage characteristic can be tailored by selecting the semiconductor materials and the doping impurities introduced into the materials during manufacture. These techniques are used to create special-purpose diodes that perform many different functions. For example, diodes are used to regulate voltage, to protect circuits from high-voltage surges, to electronically tune radio and TV receivers, to generate radio frequency oscillations, and to produce light. Tunnel, gun and IMPATT diodes exhibit negative resistance, which is useful in microwave and switching circuits. History. Thermionic diodes and solid-state diodes were developed separately, at approximately the same time, in the early 1900s, as radio receiver detectors. Until the 1950s, vacuum tube diodes were used more frequently in radios because the early point-contact type semiconductor diodes were less stable. In addition, most receiving sets had vacuum tubes for amplification that could easily have the thermionic diodes included in the tube, and vacuum tube rectifiers and gas-filled rectifiers were capable of handling some high-voltage, high-current rectification tasks better than the semiconductor diodes which were available at that time. Vacuum tube diodes. In 1873, Frederick Guthrie discovered the basic principle of operation of thermionic diodes. Guthrie discovered that a positively charged electroscope could be discharged by bringing a grounded piece of white-hot metal close to it. The same did not apply to a negatively charged electroscope, indicating that the current flow was only possible in one direction. Thomas Edison independently rediscovered the principle on February 13, 1880. At the time, Edison was investigating why the filaments of his carbon filament light bulbs nearly always burned out at the positive connected end. He had a special bulb made with a metal plate sealed into the glass envelope. Using this device, he confirmed that an invisible current flowed from the glowing filament through the vacuum to the metal plate, but only when the plate was connected to the positive supply. Edison devised a circuit where his modified light bulb effectively replaced the resistor in a DC voltmeter. Edison was awarded a patent for this invention in 1884. Since there was no apparent practical use for such a device at the time, The patent application was most likely simply a precaution in case someone else did find a use for the so-called Edison effect. About 20 years later, John Ambrose Fleming realized that the Edison effect could be used as a precision radio detector. Fleming patented the first true thermionic diode, the Fleming valve, in Britain on November 16, 1904. Solid-state diodes. In 1874, German scientist Carl Ferdinand Braun discovered the unilateral conduction of crystals. Braun patented the crystal rectifier in 1899. Copper oxide and selenium rectifiers were developed for power applications in the 1930s. Indian scientist Jagadish Chandra Bose was the first to use a crystal for detecting radio waves in 1894. The crystal detector was developed into a practical device for wireless telegraphy by Greenleaf Whittier Pickard, who invented a silicon crystal detector in 1903 and received a patent for it on November 20, 1906. Other experimenters tried a variety of other substances, of which the most widely used was the mineral galena. The crystal detector in these early crystal radio sets consisted of an adjustable wire point contact, often made of gold or platinum due to their incorrodible nature, which could be manually moved over the face of the crystal in order to obtain a portion of that mineral with a crystal that provided the optimum signal. This troublesome device was superseded by thermionic diodes by the 1920s, but after high-purity semiconductor materials became available, the crystal detector returned to dominant use with the advent of inexpensive fixed germanium diodes in the 1950s. Bell Labs also developed a germanium diode for microwave reception, and AT&T used these in their microwave towers that crisscrossed the nation starting in the late 1940s, carrying telephone and network television signals. Bell Labs did not develop a satisfactory thermionic diode for microwave reception. Etymology. At the time of their invention, such devices were known as rectifiers. In 1919, the year tetrodes were invented, William Henry Eccles coined the term diode from the Greek roots di, meaning two, and ode, meaning path. Rectifiers. Although all diodes rectify, the term rectifier is normally reserved for higher currents and voltages than would normally be found in the rectification of lower power signals. Examples include power supply rectifiers, flyback diodes, thermionic diodes. A thermionic diode is a thermionic valve device, consisting of a sealed evacuated glass envelope containing two electrodes, a cathode heated biofilament, and a plate. Early examples were fairly similar in appearance to incandescent light bulbs. In operation, a separate current through the filament, a high-resistance wire made of nichrome, heats the cathode red-hot, causing it to release electrons into the vacuum, a process called thermionic emission. The cathode is coated with oxides of alkaline earth metals such as barium and strontium oxides, which have a low work function, to increase the number of electrons emitted. The alternating voltage to be rectified is applied between the cathode and the concentric plate electrode. When the plate has a positive voltage with respect to the cathode, it electrostatically attracts the electrons from the cathode. So a current of electrons flows through the tube from cathode to plate. However, when the polarity is reversed and the plate has a negative voltage, no current flows because the cathode electrons are not attracted to it. The unheated plate does not emit in any electrons itself, so electrons can only flow through the tube in one direction, from cathode to plate. In a mercury arc valve, an arc forms between a refractory conductive anode and a pool of liquid mercury acting as cathode. Such units were made with ratings up to hundreds of kilowatts, and were important in the development of HVDC power transmission. Some types of smaller thermionic rectifiers sometimes had mercury vapor filled to reduce their forward voltage drop and to increase current rating over thermionic hard vacuum devices. Throughout the vacuum tube era, Valve diodes were used in analog signal applications and as rectifiers in DC power supplies in consumer electronics such as radios, televisions, and sound systems. They were replaced in power supplies beginning in the 1940s by selenium rectifiers and then by semiconductor diodes by the 1960s. Today they are still used in a few high-power applications where their ability to withstand transients and their robustness gives them an advantage over semiconductor devices. The recent resurgence of interest among audiophiles and recording studios in old valve audio gear such as guitar amplifiers and home audio systems has provided a market for the legacy consumer diode valves.